Okay, so today we are moving along to polynomial division. Now, there are going to be two methods that we're going to be using. When it comes down to it, if you're asked to, just divide two polynomials, you can use whatever method that you feel most comfortable with. I'm going to give you both. We're going to take some time with both, but when we move on, it's up to you on how you want to proceed. So the first one we're going to go over is long division. So now we use polynomial division to help us break down the behavior of a polynomial and to help us find the zeros, excuse me, and the factors of a graph. Well, let's jump into an example. Minus 4. Okay, so here we're going to do divide 6x cubed minus 19x squared plus 16x minus 4. We're going to divide that by x minus 2. Now, one of the reasons that we can do this, or that we would do this, is to help us factor. Okay, so right now this polynomial would be pretty tricky to just factor by itself. They don't share a common term, right? I can't divide everything by 2. I might be able to do factor by grouping, if you guys remember that. But actually that poses a problem because it wouldn't work out nicely. But what happens is sometimes we could take out one factor and then things become a little clearer and a little easier for us to continue to factor. Okay, right? So one thing to actually, I'm gonna hold off on that. We'll deal with that question after I do the division. Okay, so some quick terms. Whatever we're dividing by, we call the divisor. Okay, so the divisor goes out in front. And then we have our, division sign. So we draw the big division sign. What goes underneath the division sign is called the dividend. So the dividend goes underneath the division sign. And you want to make sure that the division sign goes all the way out and covers everything. Right. And whatever our answer is, whatever we get up here is going to be called the quotient. Okay. So there's a few methods on how you go about this. Okay. I'm going to teach you the method that I feel most comfortable with. If you say, hey, Mr. Murray, I notice another way that I feel, I can grasp this, let me know. We'll go over that together. I may introduce another method along the way. Okay, so again, just please let me know if you're lost or if you want me to stop and go back. Okay, so the way we deal with this is we focus on the first term of our divisor. Okay, most of the time, I don't want to say always, but most of the time it's just going to be the x variable. Okay, not that I'm forgetting about this, but it's not that important right now. So the first thing you want to do is you're going to compare this first term here to whatever your first term is in your dividend. So now there's two main ways to deal with this. Essentially, they're the same thing, right? It's just taking a different approach. The first way you can say it is, what do I need to multiply this term by? What do I have to multiply x by to make it look like this? Okay, well, obviously we need a 6 because there's a 6 out here, right? And then we need to get an x to an x third, we need to multiply by an x squared. So you would have a 6x squared up here, right? Again, if I multiply those two together, that gets me the first term. That's one way to look at it. Another way to look at it is a little more straightforward, is you're just going to take this first term and you're going to divide it by that first term. And whatever you get as a result, right, using our power rules, 6x to the third over x means we drop the exponent, right? We subtract exponents, x to the third, 3 minus 1 gets us 2. And whatever you get here goes up top. Okay, so that's the first step. Now, where you put this is a debate. Some people like putting it in the front to begin with. What I'll do is I'm going to put it above the squared. Okay, so just so we kind of keep organization that way. Okay, so our first step is done. We found our first part of the quotient, the 6x squared. Now that I have this, I'm going to multiply this term by this binomial. So 6x squared times x gets me 6x to the third, right? And that's what I want. I want those two to match up. But now I also have to do 6x squared times negative 2. Okay, I have to distribute that 6x squared to both of those parts. So 6x squared times negative 2 will be negative 12x squared. Okay, now down here, these have to line up with their correct exponents. If you didn't have it in the right order, this wouldn't make sense. Okay, so we got that part done. Now what we're going to do, I'm going to put this in parentheses, and we're going to subtract, right? Because if we're doing normal long division, I know it's probably been, forever since you've done this. I don't know. Right? How many times does 8 go into 9? Once. 1 times 8, right? And then we subtract and we bring down. Okay, so we're doing these steps, but now with polynomials. So I'm going to subtract these two. This part is where it gets a little confusing because we're adding this negative here. Okay, now normally we would just look like this, and you would have to tell yourself to subtract. Okay, so don't get confused at this part. So we're doing 6x cubed minus 6x cubed. They're gone. That's what we want. We want that first term to be eliminated. Now we have negative 19x squared minus negative 12x squared. So what happens is this becomes a plus. So negative 19 plus 12 gets me a negative 7x squared. We bring everything else down. 16x minus 4. Now we're going to go through these steps, but now we're using a new dividend, and this is our new dividend. All right, so I'm going to keep with this method. So my leading term is negative 7x squared. I'm going to divide that by this leading term, x, and that's just going to be negative 7x. So this is going to go up top here. All right, I'm just going to put minus 7x. All right, now again, we're going to do the multiplication. But now I'm forgetting about this 6x squared. I don't need that anymore. Negative 7x times x squared is negative 7x squared. Negative 7x times negative 2 is positive 14x. We repeat what we did up here. We put this in parentheses, and I've put a negative sign in front because we're going to subtract. Our leading terms eliminate each other. And we have 16x minus 14x. Well, that's simple. That's just going to be 2x, and we bring down the minus 4. All right, so we still have an x term, so I still have to find one last part for my quotient. What do I have to multiply x by to look at like 2x? Right? Or I can have 2x over x, and that's just going to leave us with a 2. So be careful just here. This is a positive 2. So up here, you're going to put plus 2. 2 times x is 2x. 2 times negative 2 is negative 4. We subtract that. And that's it. We have a remainder of 0, which is good, which means that this is a factor. Right, so we just did long division. I can rewrite this now. I can say that 6x cubed minus 19x squared plus 16x minus 4 is equal to, well, it's equal to the divisor times the quotient. And now that this is just a quadratic trinomial, I can factor this part. Okay, so this x minus 2 stays out there. Two numbers that multiply to 6x would be a 3x and a 2x. 2, the only factors are 1 and 2, or 2 and 1, right? And then we have that. So here, I started with this large polynomial that, if I was just asked to factor this by itself, I wouldn't really know where to begin. But once we were given one of our factors, it became much easier to break it up. Okay, but this was nice because we didn't have a remainder, right? 0 remainder means that it goes into it evenly. Another way you might see this written is just as an actual fraction, right? So you might see 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. Okay, so actually I'm going to rewrite that down here. So we can say that 6x cubed minus 19x squared plus 16x minus 4 over x minus 2. Well, what do we get when we divide those two? Well, we get what we had up there, 6x squared minus 7x plus 2. Right, now notice this first equation up here and these two and this one down here, those are equivalent. All I did was I moved this x minus 2 from one side of the equation to the other. Any questions so far? All right, let's go over one more example. All right, so we're going to divide x squared plus 3x plus 5 by x plus 1. All right, so first thing you do is you set it up in long division form. Okay. Again, normally the linear term is going to be on the outside here. Okay, make sure you don't have them switched, that you'll have a tricky time moving forward. Okay, so I'm going to use the method I used up here because it's a little more straightforward, and it actually, it gives you your answers rather than just thinking, right, what do I have to multiply x by to get x squared? Right, so we're going to look at our first term here, and we're going to take the x squared, our first term there, divided by x. So that leaves us out over with an x. So we put an x up here, right, because that's what we got over there. So once we find that first factor, we're going to distribute the x to both of our terms here. X times x is x squared. X times 1 is just 1x. I'll put the 1 there for now, just so we have it. We put that in parentheses, and we subtract. Our leading terms eliminate each other. 3x minus 1x leaves us 2x. We bring down the plus 5. Okay, now again, we do the same thing. My leading term is 2x. I'm going to divide that by x. That leaves us with 2. And that's a positive 2. I'm going to put plus 2 up there in the quotient. Right, quotient, yeah. Again, we distribute. 2 times x is 2x. 2 times 1 is 2. We subtract. Eliminated. 5 minus 2 is 3. Okay, so now you would say to yourself, well, how do I get an x to look like a 3? We can't. Okay, so we're done as far as we're concerned. All right, now we actually have a remainder. So I don't know if you remember how to deal with a remainder when you're doing normal long division with just numbers. Okay, but we would write that. So I'm going to write this. I'm going to do x squared plus 3x plus 5 divided by x plus 1. Okay, so that's what we just did. Well, that's going to give us x plus 2. So the way we deal with the remainder is we make it into a fraction. So it's going to be whatever your remainder is over what you divided by. Another way we can write it, it stinks I kind of ran out of room here. Okay, another way we can write it is I can write that the term x squared plus 3x plus 5 is, well, it's its factors, x plus 1 times x plus 2 plus the remainder, plus 3. Okay, again, these two are equivalent statements. It's just, how we manipulate them to look like one another. All right, so the last thing I'm going to leave you with, I'll give you a moment if you're finishing copying anything down. Okay, so actually before I move on, so what we can say with this too, if I want to take it a step further, is that x plus 1 is not a factor of my polynomial x squared plus 3x plus 5 because we have that remainder. Okay, so it doesn't go in nicely, so it's not a true factor, right? I can't divvy this up into, x plus 5 plus x plus 1. All right, so all right, so the last thing I'll leave you is what they call the division algorithm. So we have f of x equals d of x times q of x plus r of x. So it's kind of pretty straightforward with the names they're given, okay? But this here is our dividend, right? So that's the large number that goes underneath the division symbol. This here is the divisor. So that's what we divided by. This here would be the quotient. And then the last part would be the remainder. Right, and we saw that with both of our equations. Okay. With the first one, okay, when I wrote it like this here, okay, this was the division algorithm. This was my dividend equals my divisor times the quotient, and here we didn't have a remainder, so that was 0. Okay. Again, down here, this is the division algorithm. My dividend equals my quotient times my divisor plus the remainder. All right, any questions? I'll go back to this real quick for you. Okay, so tomorrow we're going to continue with long division before we move on. Like I said, at the end of this, you'll be able to use whatever method you feel most comfortable with. There are some advantages of this over the synthetic division. And sometimes it's situational, but yeah, we'll continue with this tomorrow. All right, any questions?